Hi, I'm Joe Bailey. I'm the Executive Director of Quest, and I want to talk to you today about developing Pareto charts. This is a quality tool that we use oftentimes within the Quest program to go ahead and help describe the sources of errors. So a Pareto chart generally is a graphical tool. It's basically a way to go ahead and take a look at errors within a particular process. And the basic idea is to have a chart with two axes. On the horizontal or the x-axis is actually going to be the sources of errors. And on the y-axis is going to be a frequency. So the idea is that you're trying to reduce the number of errors. And to do this, it'd be nice to know where the errors are coming from. So one example might be, I just recently got back with some students from Brazil, and we were looking at a Panasonic battery factory. And there's a whole bunch of different ways in which errors can be introduced in the manufacturing of a battery. Everything from the casing, to the material that goes inside the battery, to the way in which the process actually goes ahead and moves the material throughout the process, in addition to, let's say, human error. And as these batteries are misproduced throughout the process, it becomes wasted material, and it's something that has to be recycled. So you want to try to minimize that. So they use Pareto charts in their own production process to try to reduce the number of errors. And while I can't share with you exactly what their Pareto chart says, as an example, let's say their main cause of error is actually then all of the debris that's building up in the filling of the battery of the chemical material. So that would be the primary source of error and would be located closest to the origin. So let's say build up of material. And let's say for every 1,000 batteries that this error occurs about 10 times. The next possible cause might be, let's say, human error. Or somebody switches the switch at the wrong time or something like that, and maybe that happens 5 times. And a potential third source of error would be a defect in the material. Maybe that happens twice. So you can see what you have is a bar chart, whereas we move from the most likely source of error to the least likely source of error, that we see this degrading function. The last thing to go ahead and show on our Pareto chart would be actually a secondary y-axis, which I'll draw here on the right-hand side. And this is going to be the cumulative frequency. And this is going to start here at our first point with 10 defects, and then we're going to add an additional 5 to get to 15, and then we'll add in our additional 2 in order to get to 17. And you can see that this function is always increasing, right, as there's more defects, and it's going to be increasing in a degrading way, or what's called a concave function. So this then becomes a visual tool that's used within different factories and production facilities to take a look at the sources of error and to get people to recognize to reduce those sources of error. And again, it's called a Pareto chart. My name is Joe Bailey. It's been my pleasure introducing you to this very important quality tool. Thank you.